All right. Now what I've done is I'm going to use my notes from earlier today in my previous class. So I'll let you kind of catch up and write things down if you need to. We are going to start chapter 6, which is titled Factoring Polynomials. And I'll tell you this, I mean, up to this point in this class, everything we've done is important. I mean, we'll see that today, that we'll need some of the things we've done before to do what we're doing today. But at the end of it all, when a student leaves Math 0302 and enters the 0303 course, let's say this is day 1 of 0303 and you walk in, I say, hello, welcome to 0303. You better be able to factor. That's the thing you have to be able to do to succeed in 0303. So this is actually one of our main goals in this course, is chapter 6. Now, with factoring, I have to talk about what it is, okay? And I will do that. But we are going to focus today on 6.1, and we're actually only going to do this first part of it. There's 2 techniques for factoring for this section, and there's going to be more techniques later. We're just going to focus on this method called GCF today. Then next time we'll get into grouping and then move into the next section. So that's our main focus today, GCF. I'll explain what it is and everything else as we get to it. But first, what's factoring? So remember from previous, what we've been doing, on your last test, I could have asked you this problem right here, couldn't I? Multiply these. And that's because we have a monomial times a binomial, right? So what do we call that when we do that? Multiply through? Distributive property, right? So we distribute. So let's go ahead and just do that real quick. Let's multiply this. This is not factoring, okay, everyone? This is just multiplying. If I multiply 2x by negative 3x, I get what? Negative 6x squared, right? And then if I multiply 2x times positive 7, I get plus 14x, right? So the process of multiplying was just using the distributive property. That's not our goal today. Our goal today is to start with this and go back to this. That's called factoring. Okay, the reverse process. Undoing the multiplication, right? I mean, the distributive property, we're undoing the distributive property. So somehow we're going to have to go from 2 terms, right, binomial, and try to create a monomial times a binomial. All right? Okay, so how are we going to do it? Well, we'll see. I want to give you one more example to show you what factoring would be. If I asked you to multiply these 2 binomials, yes, ma'am. Yeah, I'll get that going. If I gave you 2 binomials and asked you to multiply those, you would use that like FOIL thing, right? Or what I showed you in class, because I told you I didn't like FOIL. You multiply those, you should have gotten from this x squared plus 5x minus 7x minus 35, which would be x squared minus 2x minus 35. So again, that's not factoring. Factoring would be taking this, starting with this, and ending back there. So do y'all understand the factoring is just going to be a reverse process of something we've already done? But it's much harder than what we've done to go backwards. Okay, so that's the goal. That's what factoring is. Let's look at our first technique. And that is what's called GCF, or greatest common factor. This will always be the first thing you always look for. If you ever ask to factor something, the first step, the first process you should ever think of is GCF. Now, GCF stands for greatest common factor. And this is really, the technique here is really just kind of a looking and inspecting, finding something, and then using it somehow. So there's not like, okay, add this to both sides or divide both sides. It's nothing like that. It's identification. So what I want you to do is focus your attention on the fact that we have two terms here, right? Binomial. And we're going to look at each term separately. We're going to ask ourselves, in each term, we have what? A number. I have -6 and I have 14 in the other one. Can you think of a number that divides into 6 and into 14 evenly, meaning with no remainder? 2 goes into 6, right? 3 times, and 2 goes into 14 7 times. Is that the biggest number that goes into both? Yes, right? Because what else goes into 6? 2 goes into 6, but the only other thing that goes into 6 evenly would be what? 3? But 3 doesn't go into 14. Or 6 goes into 6, right? But 6 doesn't go into 14. So the greatest common factor between 6 and 14 would be 2. What about -2, though? Does -2 divide into -6? Yes. Does -2 divide into 14? What's 14 divided by -2? -7, right? So it would work. So the point here is that, and I'm going to have to show you this, there's actually two different numbers that you could say are common factors of both these numbers, 2 or -2. So I'm going to start by using the 2 first, and I'll show you how you can do this problem using -2 after I finish this. So I'm going to write here on the side GCF. I'm trying to identify what it is. We said just a second ago that 2 is a number that goes into both 6 and 14. Now, look at the variables. We have x squared and we have x, don't we? Remember, x squared looks like, what x squared really is x times x, right? And then x by itself is just an x. What we're going to use here, like the 2, is we're going to look at these and we're going to say, what do they have in common? They both have, well, they both have at least one x, right? Do they both have 2 x's? Not both of them, right? So the only thing they both have in common is a single x, right? They both have a single x. So in my GCF, I will say that x, a single x, is a common variable factor to both of these. Do y'all see that? You see why it couldn't be x squared? Because this second one doesn't have 2 x's, right? Okay, is there anything else left? I've looked at the numbers. I've looked at the variables. There's nothing else there for me to look at, right? Agreed? Okay, now what we want to do is write down that GCF now, 2x, and then I'm going to write a set of parentheses. And in that parentheses, I need to give myself enough space for a binomial. Because remember, we were trying to go backwards on this problem? And if I start with the binomial, then whatever I have in here must also be a binomial, so that when this distributes through, I get back 2 things, right? Any questions up to this point? At this point, it's now a matter of check and inspect here. I want to try and multiply this 2x through to 2 different things, right? The first thing I want to multiply that's going to sit here, when I multiply this through, I have to create a -6x squared, don't I? So how do you turn a 2 into a -6? What do you have to multiply 2 by? -3? Good. And then what do you have to multiply x by to create an x squared? You'll need a single x, won't you? Does that make sense? Does that take care of the first term of the binomial up there? Have I created that? Yes? Okay, so now I move on to the next one. How do I create a 14, a positive 14, from a 2? Multiply by 7, right? So do I just put 7 like this? I need plus. Why do I need the plus? It's positive. Well, but that's positive also to make it binomial. You need the plus to separate terms to create 2 terms. So put the plus in between to create your 2 terms, right? And then what am I missing? Let's see. I need to turn x into x. Well, wait a minute. I already have x, right? If I already have x, I don't need an x here. So I don't put anything. Now, technically, you could say that it's really like a 1 there. But see, that doesn't change anything, does it? So I'm not going to write it. So just, that's good enough. And that's your answer. 2x, I'm just going to clean it up, minus 3x plus 7. That's it. Here's the great news when it comes to factoring. You can always check your work, right? How do you check your answer? Distribute. Multiply this times this, you should get that negative 6x squared. Multiply 2x times 7, you should get 14x. You do. So it's right. Questions? Okay. Let's try that one then. All right, how many terms do we have in this expression? 2? I should put up here factor. I need to give you some instructions. I forgot to put it up there. Factor this. So we have 2 terms, right? I can highlight them again for you. I'm also going to highlight that negative that's in there. That's important. Right, there are my 2 terms. Because it's 2 terms, I know that I'm eventually going to have to do parentheses and have enough space for a binomial. But let's first focus on the GCF. Can I find a greatest common factor? So I always like to start with the numbers. I'm looking at the number 20 and the number negative 75. And I'm trying to think of a number that goes into both of them evenly. Evenly meaning without a remainder. So what are the only numbers that go into 20? 5, 4, 2, 10, 20, right? There's a couple that go into 20, but you need them also to be able to go into 75. So 2 doesn't go into 75, right? 4, does 4 go into 75? No. Does 5 go into 75? Yes, and 5 goes into 20. Now this is where in the class you'll probably get to a point where you'll want your calculator handy because you might want to just be checking things, you know. If you can't do it mentally, you'll see on the next example, the numbers I give you are really big. So I think 5 will work. Is there anything bigger? 10? No. 20? No, 20 doesn't work either, right? So 5 looks like the biggest one. Let's go ahead and go with that. 5. Now let's look at the variables. In the first term, I have x, x, x. In the second one, I have x, x. So what do they have in common? How many x's do they have in common? X squared, right? Just 2 of them? They have 2 x's in common. You don't have to write this down. I'm just trying to illustrate it in case you have trouble with that idea. You can just look at this and say, oh, 3 of them here, 2 of them here. I need to take what they have in common. They both have at least 2. What you don't want to take is just 1, though, because you want the greatest common factor. And you don't want to forget them. If you forget them completely, then it'll be wrong, because it won't be factored correctly. So what am I going to put over here in my GCF next to the 5? X squared. Now look at the y's. 2 y's here, 3 y's here. So our common is 2, right? So I'm going to put a y squared over there. Anything else? I've looked at all the numbers. I looked at all the letters, right? All the variables. There's nothing else for me to look at, so that should be my GCF. I write my GCF out here. Set of parentheses, enough room for a nice binomial in there. You know what I mean? Don't do this. You know, give yourself some space. Remember that we're going to have to multiply through 2 times to get our 2 terms. So now I look, how do I turn that 5 into a 20? 4. How do I turn x squared into x cubed? I'll need an x, right? How do I turn y squared into y squared? Well, wait, it's already y squared, so I don't need anything, right? So are we done with that first term? We've created that? Okay, how do you get a 5 to become a negative 75? Minus 15. How do you turn x squared into x squared? You don't. You just leave it, right? Nothing is needed there. How do I turn y squared into y cubed? I need a y. And we're done. Here's something that I'll point out to you. You know how we looked at this and we came up with 5 a second ago, and we said, yeah, that looks like it goes into both, and it's the biggest one? If you do that and you're wrong, you can still check it at this step right here. Because look at these right here, 4 and 15. Do 4 and 15 have a common factor? Something that goes into 4 and 15? No, right? So you can be assured that the 5 was the largest one. What I'm getting at is, let's just say, for the sake of demonstration here, let's say that we had done this and it had turned out to be a 16 here. Then you would take a step back and go, wait a minute, hold on. 4 and 16 have a common factor still. You see? So that means there was more that could have come out, which means that 5 wasn't big enough. So it's just, be careful. If you make a mistake up here with the number, you can still recover down here if need be. But you have to take a second to look at it. But we didn't need that. It was a 15. We were okay. Okay, any questions? I like this one. Why don't you try this one yourself for a second and see if you can get it. And I'll give you the hint of being careful. What's the common number? Okay, 6 and what? 12? Okay, I'm glad you did 6. I want to work this with 6. 12's correct. That is the greatest common factor, but I want to work it with 6 because I want to see how you can still be okay with that, all right? So maybe you didn't realize that 12 went into 60, right? So you say 6. How many x's? 1. And then y's? 1. Let's just say you decided to pull a 6xy. Now you need enough room for 2 terms, right? How do you turn 6 into 12? You need a 2. How do you turn x into x? You don't. Y into Y? You don't. So I have a 2. I'm done with the first term. Now, how do I turn 6 into negative 60? Minus 10. How do I turn x into x squared? X. How do I turn y into y cubed? Y squared. If you box that, it's wrong. It's not completely factored. Because notice that you have a 2 and a 10, right? So that 2 and 10, you can say again over here, oh, wait a minute, I have a little GCF there. I noticed that 2 goes into both of those, right? 2. So you have to pull that 2 out in front again. And that 2 will come out in front and multiply basically by the 6 and become your 12. So you would have 12 out here, x, y, and now just kind of forget that this happened, all right, and go back and try and create this. So now I'm kind of where I think a lot of people who found the 12 would have been to start, right? This is an important step, though. I'm trying to turn 12xy into 12xy. It already is, right? However, you need to put a 1 there. Now, you have to put a 1 this time because if you don't, watch what happens if you don't. If you say 12xy is 12xy, I don't have to do anything. How do I turn 12xy into negative, or 12 into negative 60? Negative 5. And then how do I turn x into x squared? X, and then y into y cubed, y squared. If that's what you say the answer is, this is a monomial times a monomial. And your answer is then a monomial, not a binomial. So you have to have 2 terms in here. So you had to represent that first multiplication with a 1. Do you see how that would have worked? That's the biggest mistake I see on that, is whenever people pull something out and it's basically gone, they forget that 1 on the distribution. Does everyone understand when I use the language, we're pulling this out? The greatest common factor is actually kind of being pulled out of the binomial. We can put it back in by distributing it, but we're pulling it out to the front. Okay, I'm going to proceed. Any questions? Okay, let's look at that top one there. Now, the book goes through a certain way of doing this, trying to find your GCF for your number. I'm gonna do it slightly different way. All right. You should probably get a calculator out to do this. Let's just list out the 3 numbers. I'm not even going to care about the signs. Here they are. What number do you know goes into all of those? 5. Everyone should be comfortable with the idea that if the number ends with 5 or 0, it's divisible by 5, right? So take 315 divided by 5. What is it? 63. Now take 175 and divide it by 5. 35. Take 210 divided by 5. 42. So I know that if I factor a 5 out, right, if I pull a 5 out of all of those, I'll be left with a 63, a 35, and a 42. Now look at those. Do those numbers look like they have something in common? So you'd have to be comfortable with some of these multiples. 63 is a multiple of 9, isn't it? 9 times 7. 35 is 5 times 7. And 42 is 6 times 7 or 7 times 6. So they're all multiples of 7, which means they're all divisible by 7. So what I can say is this. 63 divided by 7 is 9. 35 divided by 7 is 5. And 42 divided by 7 is 6. You follow? And now look at the numbers that are left. 9, 5, and 6. Are any of those, do those have any common factors? 3 goes into 9, 3 goes into 6, but 3 doesn't go into 5, right? So, anything? Doesn't look like it, right? So we're kind of done at this point? So what was it that we divided by? 5 and 7, right? 5 and 7. That means we really divided by 35, didn't we? If you divide something by 5 first and then divide it by 7, that's the same as dividing it by 5 times 7, which is 35. So we actually can see from these two numbers that divided in what our GCF is. It's 35. Now, if you want to play on your calculator with these and just try and get things to work out, that's fine. This is a little bit of a systematic approach for it. But I'm going to just move on and say my GCF is 35. That's my number. Oh, I also failed to mention something here in the beginning. This is the first time we've had a trinomial instead of a binomial, right? We have three terms up there. I won't highlight them this time. I'll just separate them with these slashes. There's 1, 2, 3 terms. How do you think that's going to change our answer when we do this? We're going to find our GCF. We're going to put it in front. We're going to have parentheses. That parentheses should have enough space for a what? A trinomial instead of a binomial. Okay, we're not done with our GCF, though. Let's look at the x's. We have an x squared. That means 2 x's. X to the 4th, that means 4 x's. X cubed, that means 3. So what do they all have in common? 2 x's, right? X squared. So I'll put x squared here. How about y's? I have 2 of them, 3 of them, and then there's a 1 up there, right? We don't usually write it, but y by itself is y to the first power. So the only thing they all have in common is a single y. Agreed? So I put a y out here. Anything else? I've looked at the numbers. I've looked at the x's. I've looked at the y's. There's nothing else. So I'm ready to start trying to write this thing out. Okay, I'm going to put my GCF down here, 35x squared y. Parentheses, enough room for a trinomial. Lots of space here. How do I turn 35 back into 315? Yeah, where does that come from? Right here, right? 9? That 9 times 35 should give me my 315. So 9 times right there. And then how do I turn that x squared into, what do I need? X squared, I already have it, right? How do I turn y into y squared on the first one there? I just need a y. Now I'm going to have my next term, right? How do I turn 35 into 175? Multiply it times 5. That comes from that one right there in the middle. Now, do I just put 5? Plus 5, because I need to create the separation for my second term. So plus 5. Now, how do you turn x squared into x to the 4th? X squared. How do you turn y into y cubed? Y squared. I'm done with the second term. Now I need to create the third term. How do I turn 35 into negative 210? I multiply by negative 6, all right? Not positive, right? Because you want it to be negative. So negative 6. And then I need to turn x squared into x cubed. So I need an x. And then I need to turn y into y, but it's already there. So I'm done. I'll do a quick check, just a visual check on this. Look at my numbers. Those don't have anything in common. I don't have x's in all of these anymore, right? I don't have y's in all of them. So I'm assured now that I've pulled everything out that I can. If you do a problem like this, and what's inside this parentheses, you wind up having x's in every one of them still, that means you didn't pull enough out. your GCF was incorrect. Questions? Okay, look at this one, 5x minus 7y squared. Look at the numbers first. 5 and 7, do they have a common divisor? No? Right? Other than 1. 1 goes into anything, though, so we don't care about that. So I don't have a number for my GCF. How about x's? I have 1x here. Do I have any x's here? No, that means I don't have a common x. There's nothing I can factor out of the second one. So I can't pull an x out. How about y's? We have 2 of them in the second term, but no y's in the first term. So there's no common y's. So there's no common number, there's no common x's, there's no common y's, which means there's no GCF, okay? Basically, this thing is already factored as far as GCF is concerned. So I'm just going to say no GCF, all right? If the instructions here were to find a GCF, you would say there is none, right? There's no way to factor it that way. How about the next example? Numbers, 3, negative 4, 5. No common divisor in those, right? How about x's? X squared, okay, we've got x's there. X here, we've got an x there. Here, no x's. You have to have x's in every single term to be able to have a GCF. So you can't pull x's out. There's no number you can pull out, so no GCF. Same answer. I just want to give you some examples of problems where there are no GCFs for us to do anything with. Now, we will have a way of still attacking these, but that won't come for another, probably next week sometime. We'll start going after those. What will happen for your next test, and I'll have it for you next class. I printed them out. I forgot them on the printer. It's a cheat sheet that shows you the steps for factoring, how to factor. And the first step in factoring is try GCF. Then the second step is something we're going to get into, and third step, and there's like 4 or 5 different steps. But we're just looking at the first one today, GCF. All right, we're moving. This is a very important example. Very, very important. I don't know if you can tell, but the x squared and the plus 3 are in black, and the m's are in green. Can you all kind of tell? Not really? I'll do it a different way, so I'll do it so it's a little more exaggerated. Does red come out better? What's the best contrast? Blue? Yeah, those are highlighters. I guess I could get like really fancy here. Let me see. Let me go with like a. It all depends on the printer, or not the printer, the projector. Whatever. This projector sucks. I've got some really good projectors in some of the other rooms. Colors come out real good. That's good enough, though. You can tell that I've intentionally changed those colors, right? Okay. Let's look at this. Let's try and factor a GCF. We have a binomial. Do we have a common number? 1. That's it, right? Now, there is a 1 in front of the x squared, but we don't usually write it. But there's no number that goes into both 1 and 3 other than 1. So there is no number that we can pull out. How about variables? How about x's? I have 2 x's in the first one, right? X squared. And I have no x's in the other one. So I can't pull an x out. How about m's? I have a single m in each one, right? So my GCF should consist of that single m. Shouldn't it? So I take that single m, and I pull that out in front, and then I put a set of parentheses, and inside, how many terms will I have? I should have 2, right? Should go here and here. So how do you turn m into x squared m? So what's missing? What's missing here that we have up here? X squared is the only thing we need, right? And then on the other one, I already have the m, so the only thing that's missing is the what? The plus 3. That's not supposed to be harder than anything we've done, okay? That's supposed to be pretty straightforward. But as you'll see, I'm going to bring up the next example and try and help you see the connection here. Okay, let's take a look at this one. This doesn't look like anything we've done up to this point because we've got this cluster of parentheses mixed in with all this stuff, right? So we have like a monomial times a binomial plus a monomial times a binomial. So it's a big mess. Your instinct right now might be to say, distribute everything through. That might be your instinct. That's not what we're going for here. We're trying to factor. So please, if you could, squint your eyes, take a look at that, and do you see that that's really x squared m plus 3m? In other words, x minus 4 and x minus 4 are the same thing, right? They're identical in parentheses. So x minus 4 is a common factor in this first term, and x minus 4 is a common factor in this second term. So since they're both common, that can be my GCF. Do you see that? So we're going to essentially call our GCF on the side here x minus 4 in parentheses, okay? And now what I do is I write that GCF out front, and then I set up a set of parentheses so that I can have how many things in here? 2, right? And what are the 2 things going to be? X squared and plus 3. Essentially, it's just the thing that was sitting in front of those parentheses. Absolutely critical that you get your head around that. On a test, if you just come in there and you just distribute x squared through, let me show you what will happen. It'll be a big cluster, you know what. If you distribute, you'll get x cubed minus 4x squared plus 3x minus 12. Look at that right there. If you look at it this way, there's no common number in all these. There's no common x in all of these. And there's nothing you can pull out as a GCF, and that's ugly, right? This, you now have created the product that you want for factoring. You've created multiplication of 2 things. So if you do that on the test, that blue box, you'll get, like, out of 10 points, you'll get like -9. I'll give you 1 point just for writing something down, but that's it. Yeah, I've never explained that to you on your test. If you get -10 on a problem, that's because usually you left it blank. If it's -9, it's really way, way off. If it's -8, then there's some some bit and piece of, maybe it was a synthetic division problem, you used long division, so I took off 8 or 9 points, you know? 7 is that you maybe had a little bit there, but there's still too much of it missing, and that's how I grade each problem. -1 or 2, it's just little mistakes that I see. All right. Okay, see if you can do that one. You don't have to go through the whole process of writing GCF on the side and everything. That's just to help guide you. If you can just look at that and write what it is, then good. What is the GCF here? 2x plus 1. And you should put that in parentheses because that's the way it appeared in the problem. And then place that out front. in parentheses. What would be left here? X minus 4. It's the two things in front. What a lot of teachers will teach, or I'm not going to say a lot, what I've seen some teachers do is they tell students, whenever you see this, just whatever they have in common here, just write it down, and then just put in a set of parentheses, just put the two things in front. That's great. It'll give you the answer, but it gives you really no idea of why it is that way. The reason it is because we're actually pulling that out as a GCF. And when it multiplies back through, it gives you back this. So I don't want it to be just like this mechanical thing that you just do every time you see it. I want you to try and kind of understand what's happening. All right, those are the three problems you're going to work on right now in class. When you're done with them and you have the answers, you can show it to me, you can leave. This is your homework assignment, and I put on here do it, which means do it, okay? I want you to do this homework before we come to class next time. It's a lot of problems, but you've got to be ready starting next class. GCF has got to be done, like, down. No question in your mind you can do GCF. So what is that? That's like a good 5, I don't know, maybe 15 problems or so. I'll leave that up on the board, but I'm going to stop recording real quick.